Is time travel possible? Is a question we have all wondered at some point in our lives. Fortunately for us, science has advanced our understanding of the universe to the point where we can answer this age-old question. Scientifically speaking, time travel is the concept of movement between certain points in time, analogous to movement between different points in space by an object or a person, typically with the use of a hypothetical device known as a time machine. So, is time travel possible? Without any cliffhangers, the answer is absolutely yes. Time travel to the future, that is. However, time travel to the past is a different story entirely.
In Einstein's theory, we've got four-dimensional space, then you're prevented from travelling back in time, actually by the speed of light. It fits into the geometry in that way. Though you can imagine wormholes and these ideas that you can tunnel through and take shortcuts. Stephen Hawking has a thing called the chronology protection conjecture. And the conjecture is, from a physics perspective, it seems to make no sense. It's not a way to build a universe to allow you to be able to travel back in time and prevent your parents from meeting before you're born or whatever you do. So there's a conjecture that the laws of nature will always be such that time travel into the past is forbidden. Now that's a conjecture at the moment. It's true in what's called Einstein's special theory of relativity, and it might be true or not in his general theory. We're not sure because you can have these shortcut things, but most theoretical physicists would say we'll conjecture physics protects the past.
Some theories, most notably special and general relativity, suggest that suitable geometrics of space-time, or specific types of motion in space, might allow time travel into the past. Physicists discuss the possibility of closed time-like curves, which are world lines that form closed loops in space-time, allowing objects to return to their own past. There are known to be solutions to the equations of general relativity that describe spacetimes which contain closed time-like curves, but the physical plausibility of these solutions is uncertain. Many scientists believe that backward time travel is extremely unlikely. Any theory that would allow time travel would introduce potential problems of causality. The classic example of a problem involving causality and time travel to the past is the grandfather paradox. It occurs when the past is changed in any way that creates a contradiction in causality. For example, if you travel into the past and intervene with the conception of your ancestors, such as causing the death of a parent beforehand, you would be affecting the conception of yourself. If you, as the time traveller, were not born, then it would not be possible for you to undertake such an act in the first place. Consistency paradoxes occur whenever changing the past is possible. A possible resolution is that a time traveller can do anything that did happen, but cannot do anything that did not happen. But let's say for the moment that going back in time is physically impossible. What about travelling into the future? What makes physicists so sure that it's not only possible, but inevitable?
I know a number, which is the speed the protons go around the Large Hadron Collider. But they go around the Large Hadron Collider at 99.999999% the speed of light. At that speed, time passes 7,000 times more slowly for the protons than it does for the experimenters sat watching them going around. And that's relativity. So every time someone gets on a rocket and goes to the moon and comes back, their time will have passed slightly more slowly than the people on Earth. Therefore, they'll have gone into the future.
In 1927, British astrophysicist Arthur Eddington developed the concept positing the one-way direction, or asymmetry of time, and called it the arrow of time. But why does time appear to flow in one direction?
These were profound questions, and out of those questions arose the science of thermodynamics. It's when concepts like heat and temperature and energy entered the scientific vocabulary for the first time. Now, along with that deeper understanding emerged what is probably the most important law of physics for understanding the evolution of the universe and the passage of time. It's called the second law of thermodynamics.
Although the arrow of time seems to flow only in one direction, certain general relativity space-time geometrics that permit travelling faster than the speed of light, such as traversable wormholes, seem to suggest that time travel to the past is theoretically possible. The theory of general relativity does suggest a scientific basis for the possibility of backwards time travel in certain unusual scenarios, although the arguments, from semi-classical gravity suggests that when quantum effects are incorporated into general relativity, these loopholes may be closed. The theory of general relativity describes the universe under a system of field equations that determine the metric or distance function of spacetime. There exist exact solutions to these equations that include closed time-like curves, which are world lines that intersect themselves. Some point in the causal future of the world line is also in its causal past, a situation that can be described as time travel. One method for time travel that has been gaining traction in the physics community over the recent years are wormholes, but many scientists are not sure that they even exist, although they are permitted by the Einstein field equations of general relativity.
So yes, wormholes are allowed geometries in Einstein's theory of general relativity, if you just take that theory alone. What do I mean by that? So they really are shortcuts through space and time. If wormholes exist and you could travel through them, and they were big enough and stable enough, then you can build a time machine. When you add quantum mechanics into the mix, which is the theory of everything else, because our universe hasn't just got gravity in it, it's got all sorts of other things in it as well, obviously atoms and electromagnetic radiation and so on, then it seems like the wormholes are inherently unstable, the big ones. And if you try to travel through one, it collapses. They're such an integral part of Einstein's theory. There's a very famous paper in the 1930s by Einstein and Rosen, and they were called Einstein-Rosen bridges before they were wormholes, and they're built into the basic description of a black hole, the maximally extended Schwarzschild metric. But it was that which was discovered by Schwarzschild in 1916, just after the theory was published. Then there's a wormhole in there, right? So they're just fundamental to the theory, but most physicists believe, and Stephen Hawking wrote a paper actually called the chronology protection conjecture, these things would not be stable and you can't travel through them, so you can't build time machines. However, it's worth saying that wormholes are becoming very, very fashionable now in what's called the ER equals EPR paradigm. So Einstein-Rosen, ER is Einstein-Rosen, this thing from the 1930s where Einstein and Rosen noticed that these geometries exist in space-time, or can exist. EPR is Einstein-Podolsky and Rosen, spooky action at a distance. It's quantum entanglement. And so what now is very fashionable and looks as one of the best explanations of how information gets out of a black hole is that this plays a role. So there's a kind of a dual description. So we've got quantum entanglement, which is this spooky action at a distance thing where you separate things to large distances and they're still linked in some way. The linked in some way is starting to look possibly like you can describe that in terms of wormholes. But this is stuff that's being done now. So it's on the edge. If they were stable, or you could stabilize them in some way, then you could use them as time machines. And that's considered to be unlikely, but it's very true to say we don't have what's called a quantum theory of gravity. So we don't really, in any sense, understand the deep merger between relativity and quantum mechanics, which you need to understand to answer that question. Many physicists point out it feels like it's no way to build a universe. We've all seen Back to the Future. We all know the paradoxes that happen if time travel is a reality. So I think if you pushed most physicists and said don't be formal about it and don't say what I just said, which is we don't understand quantum gravity yet, then most physicists would say, okay, we think the laws of nature will be such that there aren't stable, macroscopic, big wormholes.
A proposed time travel machine using a traversable wormhole would hypothetically work in the following way. One end of the wormhole is accelerated to some significant fraction of the speed of light, perhaps with some advanced propulsion system, and then brought back to the point of origin. According to current theories on the nature of wormholes, construction of a traversable wormhole would require the existence of a substance with negative energy, often referred to as exotic matter. If wormholes exist, a Type 3 civilization on the Kardashev scale could use them for intergalactic space travel and also time travel. But more on that in another video. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.